Hello, grade 12. We're going to do the theory for database management, chapter 1. Right, databases in a nutshell, basically. What do we need to know before we carry on with this chapter? We need to know data warehousing. We know what data warehousing is. What is a database? It's an organized collection of data. Data warehousing is like having a very large database with many tables and records of data stored. A database is your organized collection of data accessed electronically from a computer system. A data mining is basically finding trends and patterns from a large database like a data warehouse. Data capture is gathering data from either automatic or from a user, from a person who does the job, or a control system or a sensor. So we know more or less what databases are because we used them last year, not so? What is data? Data is facts that can be analyzed and used to gain knowledge or make decisions. So what do we do with data? We collect data, we store data, we save it, and computers store data for a number of reasons. Basically, data containing instructions that a computer uses to function, data that is loaded into RAM. Data storage allows users to keep information they like to access, and data can also contain data your applications need to use, so like data files and images. So various functions that a database provides: entry, storage, retrieval, and managing how the information is organized using queries, and then database management software responsible for managing the database. This includes creating the database and tables and managing data security. That's a database management software, DBMS. The popular database management software include Microsoft SQL Server, Microsoft Access, MySQL, and SQLite. Right, now I'm actually looking at we're now on 1.1, the data collection. So we did create a database in grade 11. We added data to our tables, and we basically did it ineffectively. Okay, it's only suitable for small databases the way we added data to the tables by just typing it in. So instead of using manual entries, you can actually have different techniques to capture data. So we're going to learn about some of those. One is forms. We have a web form. The quiz that you actually do, you will do for the chapter 2, is a form itself from Microsoft Office form. Basically, the page imitates an actual physical form that people must complete, and it has all these components like check boxes, comma boxes, spinners, drop down lists, text boxes, buttons, and so on. So you can design quite sophisticated forms for banking and shopping, etc. And these are web designers can create them, and they're web forms that change the way the business is done, and also changes the way that teaching and learning is done. Right, so another way to get data into a database besides forms is tags. Electronic tags, which has a radio frequency, transmit a radio frequency, They transmit a radio frequency from the tag to the tag reader, and these tags can be used to track or identify different items, like in merchandising or vehicle tracking or pet tracking, so on. So, and then we have RFID, radio frequency identification, which are tiny chips like in the phone SIM card that stores a little bit of information. When scanned, this information is read and displayed on the computer. So if you use the correct software, it can go straight to a database too. So you have your electronic tags for vehicle tracking and pets, and in merchandising warehouses, and then you have the RFID, which is like the little SIM card, and that's got a little bit of information. So RFID is used by thousands of businesses across the world, and these are the different types of things that it can be used with. All products in a warehouse, tools in a workshop, tickets of people going to conferences, public transport, all products sold in a shop. Okay, so in the RFID, if you're in a shop and an item is purchased, the RFID tags are scanned, details about the product retrieved and added to the bill, and the item can then also be removed from the shop's inventory automatically. So your basic RFID reader will only scan the information stored on the chips and make them available to the computer, but there's software that will automatically take this information and add it to the database, which we mentioned before. So the date and the time that the RFID chip or scan can also be read. Now we are talking about e-tolls and RFID. So there's an electronic toll system in Gauteng, and the goal is to help, and motorists can purchase an e-tag or an RFID chip, and that can be read by the actual toll gate, and then it's processed and it records information of any car driving through, and that is stored in a database. All right, now digital sensors is another way of getting data into your database. It's electronic sensor where data conversion, data transmission are done digitally. For example, temperature, distance, humidity, and light. So that's more like physical sensors of those particular examples: temperature, distance, humidity, and light. And where would we use this? If you want to see how humid the area is and what's the temperature. For example, wireless sensors connect events in the physical world, motion in an area, or whether a door is opened or closed. So that would be for airflow. And then temperature or humidity. Sensors, yeah, they sense a wide range of different energy. Movement, like movement, will sense movement, will sense electrical signals, or will sense radiant energy like the sun. It will sense any pressure or thermal. You can imagine the types of systems that could be used for. Invisible online data collection. That's another way that data goes into the database. We must remember that databases are the heart of the internet, basically where everything is stored. All the information is stored from anything you see on websites is actually stored in a database, and especially important on websites where users create content like Facebook, etc. You can't. It will be an endless job for anybody to capture all your Facebook inserts manually. So websites are set up so that information entered by users automatically stored in different databases, updates and likes and tweets, etc. So that is the invisible online data collection. And your personal information, email address, etc. Usernames and passwords are stored in a database automatically too. Right, let's look at animation. Right, there's a nice animation video, but I can't. So basically an animation here showing a banking transaction. I can't get that on, won't allow me to do that. Basically it will show transactions being rolled back if a connection is broken after money is transferred from one bank to the other. Right, now we know that websites, web browsers store message, your web browser will enable you to use cookies. Cookies is a message given to the web browser by a web server. So each time the browser, your Internet Explorer or Google Chrome, well, no, Google Chrome's not, Google Chrome's a search engine, Internet Explorer, when that, no, Google Chrome is a browser, sorry. Google Chrome is a browser, Google is the search engine, but Google Chrome is the actual browser. And each time it requests a page from the server, from a server of a web page, the message is sent back to the server. So the cookie will identify people and customizes your web page for you, basically. This is in a text file. So your web browser will have a text file stored so that next time you open the page, it will remember, okay, it'll go to that cookie, in other words, little text file, and all the details about you will be refreshed. When you enter a website that uses cookies, then you might be asked if you want to. And if you say yes, so the next time you go to the same website, the browser is going to send your Google Chrome will send that cookie to the actual server of the web page that you are accessing, and set up the page to suit you. It's a lot of detailed information recorded for billions of internet users, so you can imagine that has to be done automatically too. Not automatic, sorry, invisible online data collection. They're just talking about invisible online data collection, cookies being part of that. Now, transaction tracking is another way of getting data into a database. And that basically when you have loyalty cards, and I'm sure you all know of a Clicks, Club Card, the Pick and Pay, Smart Shopper, etc. And these cards will store transaction data, the type of transaction, where it was, who performed it, the employee, the customer information, payment information. It's basically sent to a database on, invisibly. Well, you don't see it happening, you don't have to worry about it. And the data that's stored in those cards, data is stored on those cards as well. So it enhances your experience because it's tracking your browsing history, it tracks all your purchasing history, and basically it links to your browsing history and any profile that you might have, and it's good for fraud detection. And the main disadvantage is that it's of transaction tracking is the unauthorized use of your personal information. Now, another way to get data into a database is location-based data. It provides information about different things that can be shown on maps. So you have static location-based data and non-static information. Static is data such as maps with roads, street names, etc. But also farming information, government buildings, assets, electric distribution, etc., military information, and so on. Non-static is obtains the position of aeroplanes, tracking transport, or stolen vehicles, etc. That's non-static location-based data. So location-based data is just basically data about things that are shown on maps. So when you open Street View, you'll be able to see the static location-based data. And then the non-static data is the one where you have the vehicle trackers and the animal tracking, so on. Stolen vehicles, satellites, uses non-static location-based data. Right, so we have the location-based services that use software applications together with location-based databases to deliver service. And you might remember Pokemon Go. It's an example. Smartphones and tablets are also better at location-based computing. And that's obvious because you're moving around with your smartphone and your tablet. Examples of location-based computing is weather applications to tell you what's the weather in your area where you are at that point in time. Food ordering applications which allow you to use your location to deliver food to your door. And also Uber, which is car sharing services. So how do we make sense of all this data that is being gathered in so many different methods? And these are the methods. How do we make sense of all of it in all these large databases? Okay, I'm not going to go through these activities because you are doing a thing. So basically, a warehouse is where we store large number of items or large data items. Right, data warehousing is similar to how factories and distribution companies store their products in a warehouse in real life. It's just like a real warehouse. So they call it a warehouse because it's a lot of data that's stored. But the data in the data warehouse is not normalized in the most efficient manner. Basically, it just takes the data and stores it, and there could be lots of redundancies and additional and basically they can use lots of additional storage space. What's normalized? Normalization is the process of refining the structure of a database to minimize redundancy, improve integrity. Now, when you have redundant data, it means you're using up too much space and you don't have integrity of data. So we'll get to those definitions soon. So redundancy occurs in the database when the same piece of data is held in two different places or more. Right, the goal of a data warehouse is to make data available and ready for analysis. So we need the data in the data warehouse so that we can, use it and analyze it. And unfortunately, it's not normalized or anything, most of it. So it's open to multiple people in different departments of a company or countries, and each of these people can access the data and create graphs and reports useful to them. So the data warehouse does not contain copies of the original databases. It's a new database. It's created to hold structured data from multiple sources. Right, a data warehouse versus a database. A data warehouse and a database are similar, but they have different purposes. So a data warehouse stores a larger quantity of historical data, and all data from various databases are available, whereas a database stores current transactions and enables access to specific transactions for ongoing business. Right, and then those activities, and data mining is the way that we can go and access the data in the data warehouse. So if you want to find trends and patterns between different sets of data in large databases like a data warehouse, then you use data mining to find the patterns and the trends of different sets of data. You have to know how to select the right data from large amounts, called big data. There's a word for large amounts of data. And then you can go and get trends and patterns. So when you marketing, data mining is used to explore increasingly large databases to include the market segmentation. So you're looking at customers' age, gender, etc., and what they prefer, and find patterns and trends, and then you can guess behavior in order to direct personalized loyalty campaigns. So they use it for marketing, for sales, in other words. Predicts which users are likely to unsubscribe or subscribe, and what the interests are, and what the mailing list should include, etc. So to mine data, what do you have to do? You have to extract relevant data, find the right data to use, and then look for patterns in that data, and then get knowledge from the patterns. Those are the 3 steps of the data mining process, and they say we're going to look at those 3 steps in more detail. So extracting the relevant data. Well, we need to know which fields, fields are the columns, which database table we're going to use, and what conditions are used. So data basically is going to be extracted using SQL. And we introduced you to SQL last year, if you can remember. And this SQL is a programming language specifically to manipulate and extract data from databases. And we use queries to do that. Which columns, which tables, and why we want those particular things. Only data that meets these requirements will be extracted, and then we look for patterns. So that is how we're going to go and extract the relevant data, by using SQL queries. Then we look for patterns in the data. It's impossible to look at each data on its own. You need to look for patterns. So you might, and you can just imagine what those are. Patterns can give us knowledge, just like in the marketing. So you've basically got an overwhelming amount of basically once you've got a pattern, you've got all your disorganized data into a few useful facts. It allows you to understand what happened rather than rely on vague information. So data mining is very important. Right. So, as an example, we have the tour company requires the use of a database management system to store details of tours and tour guides. A record of the tours and the agent responsible for each tour is stored in a table called TBL Tours. The first 5 records are shown below. There's probably could be millions of records, in other words, the rows. So we're going to see. Give examples of 3 questions that can be analyzed using the data. So this is a tour table of all the different tour destinations like Kruger National Park, Drakensberg, etc., etc. We have a start date, an end date, and a tour guide. And the guide telephone number. So we have a tour guide who has a telephone number, and the tour guide does many tours. So we can actually extract data about how many tours a specific tour guide did. We can extract data about the dates of the actual tour. Maybe want to know everything, all the tours that occurred in the month of July or August. Let's go and have a look at our memo for this question, 1.6.1. Is it? It's not. Yeah, it's 1. What? There we go. How long is each tour? So basically you have the length of a tour, but you can subtract, you can subtract the dates to see how long the tour was. So this was 9 days and this was 4 days, etc. You can also, which ones are the most popular times of tours. So you might have many Kruger National Parks. So in other words, in this case, there's 2 Kruger National Park. No, there's 3. So Kruger National Park was the most popular. So it's just going by this small amount of records here. The records are the rows, remember, and the fields are the columns. Okay, what must you do to mine the database? Run queries. Basically, obtain access to the data, extract relevant data, and look for patterns. How do we extract the data? We run a query, and then we look for patterns. But first you must have access to the data, extract the data, look for patterns, and develop a strategy. And to gain access to a database, which of the following options can you legally apply? Well, you can buy access. You can buy access to the database. You could just request it nicely from one person as yourself, or you could use a scraper or the website's API to record data directly from the site. That sounds a little bit illegal, isn't it? That's just me personally saying that. Now let's move on to, oh no, it is legal using a scraper. I don't even know what a scraper is. Go look it up in the internet. The illegal ones is you must not hack into a database. No. Buying access is legal, but asking someone to get access is illegal. Giving money to an employee to get access is illegal. Use a free database from the internet, that's illegal. But I don't understand this scraper or website's API to record data directly from the site. Well, maybe that's if you're an employee, then you can do that. Right, which website does not provide data sets for free? There's like 4 of them over here. And that is a little bit of a general knowledge question. So, University of Pretoria does not provide data sets for free. All the others do. Right, now, What must you do after you obtain access to the database? After you obtain access, you must extract the information, remember. And then you look for patterns. But let's just see what the book answer was. Yep, extract the information. This is an example of a pattern that emerged from the tour database. Starting date, the length of the tours, that's we're supposed to go and look at that, but the answer is Senzo does every second trip. But I don't want to waste any more time because it's going to take too long. Anyway, the final step of in the data mining processes is obtaining knowledge. Oh no, the final step is developing a strategy. So after you obtain knowledge, then you make a plan. A strategy is like a plan. You've got to make a plan once you've got your knowledge. Okay, which of the following targets are SMART? And SMART, let's see, where's SMART? S-M-A-R-T. This is a term that I cannot remember referencing. But anyway, we'll go and have a look at the answer book. Right, so they say this one, by decreasing the price of a car train tickets by 10%, you hope to increase the number of passengers by 20% over the next 6 months. So they say that's smart. So that was the middle one, number B. By decreasing, but this one, yeah, by decreasing by 10%, no, it was C, 10%. You hope to maintain the increase in the number of passengers by 20%. By decreasing the price of car tickets, yeah, because you're not actually doing anything logical there. And over here, you don't know how much you're going to decrease the price of the tickets by. This one is decreasing the price by 70%. That's way too low. You can't, too much. You can't decrease it by 70%. You're not going to make any kind of profit. So this is the smart target to take on. Okay, 1.4, caring for and managing data. Right, metadata. Metadata is data about data. It's like, what's the size of a string? How many characters are you going to put in your text data type? Are you going to use a real number? Are you going to use a range for your integers so that you don't, you don't want to, you can have a small integer which will have a small amount of range from maybe -100 to 100, or you're going to use a very large integer range for storing your data in. So the metadata is telling you what is the data about the data, what time was the data collected, what type of data is it. And data is valuable for many reasons. So we know that online shopping can charge owners a fee for placing an advertisement of their house or something on the website. But the only way in which owners will be willing to pay the fees if the database already contains many other products. To gather data to sell products, the website's creator can ask sellers to enter the important data for their products on the no, that doesn't make sense to me at all. Metadata is basically data about data, but they're talking about the value of data. Okay, why is data useful? You can ask yourself these questions. Will I ever use this data in this field or this column? Has anyone else used the data? What columns or fields do I need for my application? What fields would I need or columns would I need for my application in the future? This is questions to ask to decide if data is valuable. Are you going to use it? Is it really important for your purposes? And you can determine whether certain types of data are valuable to record in your database. It's very important when you design your PAT program that you actually only use fields that you know you're going to use in your program. Otherwise, you're storing data unnecessarily and you don't need it. Even in the future, maybe. You must look at the future as well. And so once you've determined it's valuable, you need to ensure the data is of high quality. And these are characteristics of quality data. Accurate means it's basically must be precise, correct, entered correctly, mustn't be faulty or fake. Consistent It mustn't contradict other parts of your database. And current means up to date. In order for your your information to be of high quality, then it must be complete. So it's almost as bad as inaccurate. If you haven't got all the data that you need, or it's misleading, then it's not complete. Relevant means it's relevant to the people who are using it. So those words you must study and understand. How to protect data. Well, there's several different threats to data, including incorrect data entry or any data corruption or data loss or accidental data deletion or purposeful data deletion or unauthorized access. And there are 8 tools that you can use to protect your databases from these threats, and these are validation, verification, integrity check, logging changes, data wares, access control, parallel data sets. So we're going to go look through all of those. Data validation is to check whether the data is accurate in the correct format. And it also checks whether a database is consistent and accurate, and this can be used to prevent certain types of unauthorized access. For example, if you're recording data for a government survey, you can ensure that all the ID numbers are 13 digits long, and that prevents you from accidentally adding incorrect ID numbers to the database. You can also do other checks on ID numbers to make sure that the certain digits on the date part of the ID number are correct in the range and so on. That's data validation. Now, data verification is a manual technique to make sure the database is correct and accurate. There's two ways. So that means somebody, a person, this can't be done by the computer. Verification can only be done by a person. Basically, he has to go and read and check the data. And that's a full verification, you're checking all of it. Sample verification is in which a randomly selected sample is checked to ensure that there aren't any systematic errors. Now, verification basically means, did they spell your name correctly? Is there a capital letter for your first name and so on? That's verification. Then that's a physical person actually going through all the data and checking all of that. Right, now integrity, that is all about being reliable and accurate and trustworthy. And that obviously ties in with data security, so that data is not corrupted. So reliable, accurate and trustworthy over its entire life cycle. And how do we check that? DBMS, Database Management System, has integrity controls built in, like a data validation and range check, and access control even. Also refers to a system, several automatic maintenance processes to prevent data corruption. So this will be built into your database management system, and you can use those tools. There's a range that you can use, and an error message that can come up, and that's not in, and the actual built-in data validation in your tables. Right, now the other way to make sure your data is, what is the whole point of this? Protecting data, yeah. Logging changes. That's the process of recording any changes that the user's made, and it's sort of like an audit trail. So it doesn't protect a database, but it does discourage people from sabotaging, because this audit trail can tell you who made the changes, what that person changed, and when those changes were made. So that's a cool thing. Right, now data warehousing, that's a technique for storing data from more than one database, as we talked about earlier. How's this going to protect data? It's not really a security tool, but it can help improve data integrity in several ways. Well, how does it do that? It makes your incorrect data entries more visible by allowing data analysis. And also data loss is more visible. because data warehouses can allow the problem to be fixed, and data warehouses can also be used to recover critical data if it's deleted and or corrupted. All right. But data warehouses are a potential security weakness, and you could have all the best features in the world of your database, and it would be not matter if hackers could simply access your data warehouse. So we have access control. Controlling parts of the database that users have access to. You can limit the number of people who can change anything in the database, and you can reduce the damage that a single user can do to a database. And this is especially important when you have many users. And there are 3 important ways to control access to your data. Obviously with passwords that only the owner of a username can log into. So yes, there is a way you can put access control on your Microsoft Access database. Then there's user rights. In other words, you can decide what username can access which tables and fields. Fields are the columns, remember. And this also can prevent unauthorized access. And then good database security ensures that the data is secure and that outside people cannot find other ways to access. Okay, fine. Right, access control on a large news website, obviously news writers and so on. Well, they're just giving examples of different databases that need access control, like news websites and so on. Right, now another way to make sure your data is secure is to have a parallel data set, in other words backups. It's the most important tool to protect data from data loss and corruption. So you have backups, and they call them parallel data sets. The database is checked at intervals against a perfect copy of it. So you have a parallel data set, and that is the perfect copy of your database, and you check it against your original to see that nothing has been deleted or corrupted. So a company like YouTube would break the database into small pieces and have multiple backups of each piece. Imagine YouTube is a very large database. A system can automatically load an existing backup while creating new backups. Alright, so they should be protected. The backup should be protected as securely as the database itself. And obviously physical protection as well, like access to the room where the database is stored and which computer and so on. I've had enough of that now, and you know all of these in the quiz, so you should be fine. And please remember to do as much studying and reading up as you can. Time is very limited.